Hello everyone, Mr. Fawcett here, and we are back with another AP Calculus lesson. And unless I decide on putting another topic in here, this will conclude our AP Calc AB curriculum. So that's exciting. Last video of this unit and the curriculum in general. We are going to continue with using the washer method to figure out volume of solids that are formed by regions being rotated around a certain axis. Today, the axis is just going to be something other than the x or the y axis. In our previous lesson, it was either x or y. Today, it'll be something else. But again, concept will stay the same. Let's take a look at this problem right here. It says, let R be the region in the first quadrant bounded by the graph of y equals the square root of 2x, the horizontal line y equals 6, and the y-axis as shown. Write, but do not evaluate, an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 7. And we are going to evaluate it, but it'll be one where we just punch into the calculator. Okay, let's make a sketch of what this is going to look like. And I'm actually going to give us a bit more room here. Okay. So we're revolving this around the horizontal line y equals 7, which is not on our graph, right? This goes up to y equals 6. Y equals 7 would be about right there. So let's go ahead and draw this line on our graph, because that is going to be our axis of rotation. All right. Now, again, we're going to have to use the washer method for this because there's some area between the region and the pink line that when that's revolved around the pink line, the axis, we can't count that volume. So let's just sketch a couple of these washers. Oops. Okay, so those would be the disks if I just revolved that entire region around that pink axis. But remember, I don't want to include the volume formed by wrapping or revolving this green region around. So let me go ahead, pause the video, and I'll put what that would look like up there. All right, so I just highlighted, or I just sketched in blue the topmost washer and the bottommost washer. And you can kind of see that the region that we want to calculate the area of is everything except for that green tube in the center. That green tube in the center is not formed by revolving R around the pink axis, so we don't want to include it in our final volume. So let's look at how we would calculate the area or the volume of one of these washers. And we'll actually just think about this one in the middle. Sketch it out in orange. So if I want to calculate the volume of that, I would do the volume of the pink disk minus the volume of the green disk. That would give me the volume of the orange washer. So volume of the orange would be volume of the pink, so pi r squared times h, minus, right, the volume of the green, so pi r squared times h. And we'll actually, again, we have two radii here, so we'll use r sub 1 and r sub 2. The radius of the pink, well, that is the distance between, this could be r sub 1, that is the distance between the line y equals 7 and the function. So we'll just subtract the function from 7. That would give us the distance. We're going to get pi, in parentheses, 7 minus the square root of 2x squared times h. The radius of my green disk, well, that's constant, right? The radius of every green disk is just 7 minus 6, right? Because that's a cylinder, so the radius of the cylinder is the same all throughout. It's the line y equals 7 minus the line y equals 6. So we've got 7 minus 6 quantity squared times my h. I can also substitute in for these h's, right? The heights of these disks or the heights of these small cylinders are dx. Everything is in terms of x because my washers are perpendicular to the x-axis here. And now we can just do some simplifying. So I'm not going to square this binomial right here. I'm just going to leave it as is because we are going to use a calculator to evaluate this. I will simplify the 7 minus 6 squared though. That'll just give me pi times dx. I also need a dx over here. Can't forget that. And I will now factor out a pi and a dx. So I'll get pi, and I'll put the pi at the beginning. I'll have pi times the quantity or the difference 7 minus the square root of 2x minus 1. We're squaring that over here. 7 minus 2x quantity squared times dx. So that would be the volume of one of the washers. And of course, if I want the volume of all the washers, well, I just need to integrate over the entire interval. So the volume of the solid is the integral from 0 to 9, or in terms of x, we're on the x-axis, 0 to 9, of pi everything in my brackets, end it with a dx, and we are ready to jump to the calculator. But again, the idea here is you understand how we set the integral up. By this point, we should be comfortable working with the calculator, but we want to make sure we understand how the interval or how the integral is set up. So you can do it this way. I know we've talked about some other ways. Whoops, looks like I cut that part of the washer out. We also talked about just doing a difference of integrals, right? This represents all the washers, the sum of the washers. But you could also do the difference of all the pink disks, the volume of all the pink disks, minus the volume of all the green disks, right? It's kind of what we did over here. We were just looking at a single the single disks, right? But let me show you what I mean, just so we can. Actually, I'll just do it over here, so we can show you. Right. So the volume of the solid, we could say that is equal to the volume of all the pink disks. So from 0 to 9 of pi times the quantity 7 minus the square root of 2x squared dx minus the volume of all the green disks. Right, so from 0 to 9 of pi dx. If we subtract these two integrals, right, we're going to get what we get in blue up here. So it's really up to you. If you want to do the work over here to find the volume of one washer, and then just write a single integral to find the volume of all the washers, that's fine. If you just want to jump right to a double integral, or not a double integral, but the difference of integrals, right? One integral representing the volume of the big disks minus the integral representing the volume of the smaller disks, and just subtract, that's fine as well. Both of them are going to get you the same thing. And it's kind of cool to think about it both ways, right? One way may make more sense to you, or maybe you understand it one way and you want to also figure out what I'm talking about when we go through it another way. But again, focus on why we build the integrals a certain way rather than just trying to memorize, a certain formula or looking for patterns, etc. You really want to have an understanding of what each piece of the integral represents. All right, when you put this into the calculator, I'd pause the video, do that just to make sure you punch it in correctly. You should get approximately 226.19 5 if you round, 194 if you truncate. Okay, let's do one example where our washers are perpendicular to the y-axis. Got a bunch of problems in this lesson, so we're going to skip all the way down. Here's one. This time we just have to set up our integral. We do not have to evaluate it. It says let R be the region enclosed by the line y equals 1, the line x equals 8, and the curve y equals log base 2 of x. This is a good one because we'll look at a relationship we haven't looked at too much between logs and exponents. It says a solid is generated by rotating R about the line x equals 2. Which of the definite integrals gives the volume of the solid? Okay, so we are rotating around the purple line. I will draw in a couple of the washers just so you can kind of get a visual, but I'd also encourage you to try to draw those in on your own first. All right, so my big discs are the ones in pink, the smaller discs are the ones in orange, and I highlighted one of the washers when I subtract out the orange disc from the pink disc, and I highlighted that in green. You'll notice the topmost disc is the same for the orange and the pink, and the bottommost disc, the orange is just a point, and we just have that large green disc. So this would be like a cylinder with a little, top cut out of it. A top that you may like spin on the ground, or you could think of it looks like a tornado is being removed from the cylinder. Important to note that our washers are perpendicular to the y-axis, so our integral should be in terms of y. So we need to keep that in mind when we're writing it. Let's write out a formula for the volume of one of the washers. We'll just think about the one in the middle, the one that I shaded in green, and then we'll set up an integral. So the volume of the green washer is going to be equal to the volume of the pink, so pi r squared times h, minus the volume of the orange. And we will use R2, R sub 2, and R sub 1 here, because our radii are going to be different. Let's think about the radius of the pink. All right, so we should notice that the radius of the pink does not change. That radius is always going to be 6. We're going from x equals 2 to x equals 8. So I'll get pi times 6 squared times dy. The radius of the orange does change. And you'll notice that that's the distance between the blue curve and the line x equals 2. Now, we could just do top minus bottom, but we need to make sure that it's in terms of y. Right now our function's in terms of x. So we just need to rewrite this in terms of y and we'll be good. Whatever the base of the log is, that's the base that we need to raise each side to. So I apply base 2 to both sides, so I get 2 to the power of y is equal to x. The exponential base will be whatever the base of your log is. That will undo the log, right, and get the x by itself. So now if I do top minus bottom, I get pi times the difference of 2y minus 2. Don't forget to square that. If you guys knew how many retakes I did of this video because I kept forgetting the square there, kept forgetting to write it down, well, let's just say it's not good. Too many. Let's go ahead and simplify. So I can simplify the 6 squared. I get 36 pi dy. In orange, I actually am going to multiply this out because our answer choices, you'll notice, they did square that binomial. So over here, I'm going to do that. 2 to the power of y minus 2, square that. You could pause the video and work out the math on your own. Turns out that you're going to get 2 to the power of 2y minus 4 times 2 to the power of y plus 4. So that's what's going to go over here. And again, I encourage you to pause the video and work through that squaring process because it's a little different now that we have an exponential expression there. And then I'm just going to combine, or I'm going to factor out the pi and the dy. So I get pi out in the front. Then I have 36 minus this entire quantity. Sure, we have this as plus 4. Dy, simplify one more time. I get 32 minus 2 to the power of 2y minus, plus 4 times 2 to the power of y dy. I am ready to integrate because this represents the volume of one washer. So by integrating, I'm going to do this up here, the volume of the entire thing. On the y, we are going from 1 to 3. Just copying everything down there I have in green. And let's hope it matches. Well, strictly based off of limits of integration, we know that it's b, but let's make sure everything else matches. 32 is positive, negative 2 to the power of 2y is negative, and 4 times 2 to the y is positive. So our answer choice is B. Okay, that's going to do it for this video and possibly this curriculum. As always, enjoy the rest of your day, and I would say I look forward to seeing you next time, but this may be the ending video. So just enjoy the rest of your day.